right. Okay, so let's say for this example, we want to solve -5 square root of 3 secant theta minus 8 equals -18. Oop, forgot to put the domain for it. Where theta is in the interval, actually I'll just write it out the way it's been written out already. (360°). So sometimes you may see it written in the homework as 0 to 360°. Same thing. Oop, that should be a parentheses. Okay. So with this one, first thing you want to do is solve for secant. Let's say secant theta instead of writing out the whole thing. Okay. So we solve for our secant of theta. So we have our -5 square root of 3 secant of theta minus 8 equals -18. Add 8 to both sides. So we have -5 square root of 3 secant of theta equals -10. So clean that up a little. Okay. So divide both sides by -5 square root of 3. That gives us secant of theta. -10 divided by 5 is 2. So that'll be 2 over square root of 3. Okay. Now with this one, you want to remember that secant of theta is equal to the reciprocal of cosine of theta. Okay. So that means that secant of theta equals to 2 over square root of 3 will give you the same solutions as cosine of theta equals square root of 3 over 2. So you don't have to remember the secants and cosecants. All you have to do is remember the sine and the cosines. And when the secants come around, you just flip your cosines. And when the cosecant come around, you flip your sine. Does that make sense? Oh, okay. Okay. So we know that cosine of square root of 3 over 2, well, cosine of theta equals square root of 3 over 2. And remember, that's positive in quadrant 1 and quadrant 4. Okay, so we know this is true when theta equals 30 degrees in quadrant 1 and theta is equal to 330 degrees, because remember that would just be 360 minus 30 in quadrant 4. Okay, so since it's true for cosine of theta, it's also true for secant. So we also know that secant of theta equals 2 over square root of 3, And if you wanted to, you could rationalize the denominator by multiplying both by square root of 3. So that would be 2 square root of 3 over 3 if you wanted to. It's also true for theta equals 30 degrees and theta equals 330 degrees. All right, so any questions on that one? Move that over a little bit. Done. Okay, so let's say for our next example, I meant to have this after the cosine one with the negative value, but this one will work also. Say if we wanted to solve secant of beta minus secant of beta times sine squared of negative beta equals negative square root of 2 over 2. All right, so just like before, we want to get rid of that negative beta. Okay, so we know that sine is an odd function. Okay, which means that sine of negative beta is just equal to the negative brought out to the front of sine of beta. Okay. Now the only thing is, this is squared. So our sine squared of negative beta remember, that's just sine of negative beta squared. And remember, sine of negative beta is just the negative brought out to the front. So that's negative sine of beta squared. And you have a negative squared, it's still going to come out to be sine squared of beta. Now, if it was to the third power, it would be negative. But since it's squared, and you have an even exponent, that's why it comes out to be positive. Oh, bring that down a little bit. Okay, so we can actually replace our sine squared of negative beta with sine squared of beta. Okay, so that gives us secant of beta minus secant, let me kind of separate that a little bit. Secant of beta times sine squared of beta equals negative square root of 2 over 2. Okay. Now here we can factor out secant of beta. Okay, so if we factor out a secant of beta, that becomes 1 minus sine squared of beta. Equals negative square root of 2 over 2. Okay, so going back to our Pythagorean trig functions, or trig identities, we know that sine squared plus cosine squared is equal to 1. So if we subtract sine squared from both sides, cosine squared equals 1 minus sine squared. Okay. So that 1 minus sine squared, we can replace that with cosine squared. Okay. So we have secant of beta times cosine squared of beta equals negative square root of 2 over 2. Okay. We also want to remember that secant of beta is equal to 1 over cosine of beta. So that secant of beta becomes 1 over cosine of beta times cosine squared of beta equals negative square root of 2 over 2. So just like if you had x squared times 1 over x, one of those will cancel out. So that cancels out, and that becomes 1. So we have cosine of beta equals negative square root of 2 over 2. So all of that simplified to that one trig equation. Okay, so we know that cosine of beta is negative in quadrant 2 and quadrant 3. Okay, so we know in quadrant 2, this is true. I'm not saying this, I'll just go ahead and write out the whole thing. Cosine of beta equals negative square root of 2 over 2 is true for beta equals 3 pi over 4 in quadrant 2, and beta equals 5 pi over 4. Actually, I might as well, yeah, I can put it here. In quadrant 3. Okay, so 3 pi over 4 and 5 pi over 4 would be your answer. All right, so any questions on that one? All right. Still writing. It looks like everyone's done. Okay, and actually this one section should have been done back when we were doing the area of a circle and everything else, but it's, for some odd reason, they didn't put it there. So we're going to cover it right now. I think we went over the formula, but they just misplaced the actual assignments, which isn't, it's not too bad. So finding the area of an oblique, an oblique just means non-right triangle. Using Heron's formula. Okay, so for example, use Heron's formula. Go clean that up a little bit. find the area. For, let's say if you have a triangle, we know it's not a right triangle. Let's say this is side 7, this is side 14, and this is side 13. Excuse me. Okay. So Heron's formula is just the area is equal to the square root, and I'll just put a little line through my S so it doesn't look like a 5, times S minus A times S minus B times S minus C, where S is just equal to A plus B plus C divided by 2. And A, B, and C are just your sides. Straighten that up a little bit. Okay. So the first thing you want to do is find your S. Okay, so we know that S is equal to A plus B plus C divided by 2. So you can do it in any order, just 7 plus 13 plus 14 divided by 2. So it's 34 divided by 2, which is 17. So we know our S is equal to 17. And then next you're going to plug that. Oh, yes.
Why is it over 2 when the formula is over C?
Oh, did I put over? Oh, that was my mistake. I think I was just writing too fast. Thank you. All right, so we have our S. Second step, just plug into our formula. Okay, so we know our area is equal to the square root of S times S minus A times S minus B times S minus C. Our S is 17. So that's just going to be the square root of 17 times 17 minus 7. Straighten that one up a little bit. Times 17 minus 13. Times 17 minus 14. So that gives us the square root of 17 times 17 minus 7 is 10. 17 minus 13 is 4. 17 minus 14 is 3. Okay, so you plug that into your calculator, you end up with 45.2 as your area. All right, so that one's pretty straightforward. All right, any questions on that one? All right. Leave that up for a few seconds. Okay, so now we're going to start with polar coordinates. So far we've been using either, you can call them rectangular or Cartesian coordinates. So let's say if we have some point here, this is our x-axis, this is our y-axis, and this is our point x comma y, where we go x points to the right and y number of points up, which gets us right there. With polar coordinates, they change it from just going x comma y, just going to the right and up, or to the left and up, or to the left and down, or to the right and down. What you do is they go out a certain distance, and then they swing it up to end up right at the same point. Okay. So they go out a distance of r, which is your radius, and they swing it up a certain number of degrees, which is your theta. Okay. So you can get right at the exact same point where your x comma y is your rectangular or Cartesian coordinates, and r theta are your polar coordinates. Okay. It's the exact same point, just a different method of getting there. Oh, bring that down a little bit. There we go. All right. Any questions so far? No. All right. Okay. So we know with the unit circle, we knew that cosine of theta was equal to your x, and sine of theta is equal to your y. That's just on a unit circle. Okay. Now what if your radius isn't 1? So on a non-unit circle, cosine of theta is equal to x divided by your radius. Sine of theta is equal to y divided by your radius. Which is why on a unit circle, when your radius is equal to 1, it's just x and y. So you can really look at this as more of a general, I guess it's general description or definition. Okay. So if we multiply both sides by r, our radius, we have x equals r cosine of theta, and y would equal r times sine of theta. Okay. And you would use these two to convert from a polar coordinate to a rectangular coordinate. From polar coordinate to rectangular coordinates. Now converting from rectangular to polar is a little bit different. We know that tangent of theta is equal to, let's say, sine of theta. In this case, let me make sure because it cancels out anyway. So our sine of theta, clean that up a little bit, over our cosine of theta, where the two r's cancel out. So you end up with tangent of theta is equal to sine of theta over cosine of theta, which is just y over x. Now, if we apply tangent inverse to both sides, we end up with tangent inverse and tangent cancels out. So we have theta equals the tangent inverse of y over x. And we also know that our radius, just looking at kind of the right triangle that's created up here, you have x squared plus y squared equals the radius squared. Which is also your radius is the square root of x squared plus y squared. And these are what you would need to convert from rectangular to polar. Okay, so you use a different set of formulas depending on what you're converting to. There we go. Okay. Now from polar to Cartesian or polar to rectangular, it's the easiest one. Because you're just really plugging in your r and your theta. Still writing. Looks like everyone's done. Okay, so let's say if you wanted to convert, might as well restart.